Okay, in Unit 2, we are going to be taking a look at matter and the organization of matter. One thing I want you to keep in mind is when we talk about chemistry, what we're talking about is we're talking about electrons. Electrons, electrons, electrons. And in fact, the only thing that matters in chemistry are the outer electrons. What they do here is they go back to grade 10 and 11 and they start to talk about the basic organization of an atom. So I'm going to go over that, and we're going to look at two terms, isomers and isotopes. I think they focus on isotopes when they're discussing this within this unit. Now, the last part of U2A1 is an assignment that you have to do, and you have to come up with the history of the atom. So basically, they give you some suggested scientists, throw in your own, try and make it creative. I like visuals, so if you can throw visuals into your timeline, I do enjoy that. Okay, so the whole idea there is to show you how we figured out in timelines when things came about in the atom. You might hear a storm in the background right now. I apologize if that's interrupting anything. Okay, first thing I want you to do is have a periodic table. And in that periodic table, you should look for two numbers. The atomic number is this number right here. Yours might be in a different place, but if you look up oxygen on your periodic table and you find the number 8 somewhere, that's the atomic number, meaning that oxygen is the 8th element on the periodic table. The other number you're going to try and find is going to be harder to see. Mine says 15.999. So you're looking for the number 15.999 or something close to that, and that's the atomic mass. And what we're going to do right now is we're going to talk about what these numbers mean. So I'm going to take lithium 3,7, okay? So this was actually lithium 3, it's the third element, and it was 6.9 is the atomic number, but we round that up to 7. Let's talk about what everything means here. The 3 means, this is the atomic number, by the way. This means that it's the third element on the periodic table. It means that it has 3 protons. That's the short form protons because it's positive. If an element has 3 protons, it also has 3 electrons because these balance out. The charges balance out. If you want to know the number of neutrons, you subtract 7 minus 3 is 4 neutrons. Now, if we were to do a Bohr-Rutherford diagram of this, and I'm not saying you have to, but if we were to do that, we would put our protons and neutrons in the nucleus. These are basically the same size. They're very large compared to the electrons. And the electrons we would add in like this. You have 2 electrons in the first shell and 1 on the last shell. Now, if I was to do something called a Lewis dot diagram, which is the more useful diagram in chemistry, I would just write down Li and I would give it 1 dot. That 1 dot represents the outer electrons in the shell. Those are the only things that are important in chemistry. If you want to know how many electrons that you put around an element, look up where it is on the periodic table. Anything in this column gets 1 dot. Anything in this column gets 2 electrons, 3 electrons, 4, 5, 6, 7. If you were to draw these, you do 8, but they're non-reactive. So those are the only elements we worry about. Let's do another one of these. If we had fluorine and its atomic number is 9 and its mass number is 18.9, we would round this up to 19. Here's a question: how can we get a number that's 18.9? It means because not every fluorine has the same number of neutrons, and this number is like an average. Some fluorines have 18 neutrons, have 9 neutrons, and some fluorines have 10 neutrons. And most of them have 10, so the average is 18.9. Once again, it's the 9th element, 9 protons. We have 9 neutrons, and 19 minus 9 is, we have 9 protons. We have 9 electrons, and 19 minus 9 is 10 neutrons. So I'm going to do a Bohr, Rutherford, and Lewis dot diagram. Just try and bring back some memories of grade 9 and 10 for you here. So we have 9 protons, we have 10 neutrons. When you add the electrons in, the rule is 2A8 in the Bohr-Rutherford diagrams. So 1, 2. Please watch what I'm about to do. Go back over this video a couple of times till you get this. The second set of electrons go like this. 1, 2, 3, 4. Because they're negative in charge, they repel each other. But then electrons have spin. So 2 electrons of opposite spin will attract each other. So you add them in singularly first in the second column, or the second orbit, sorry, and then you would bring them together in pairs. You do the third thing in the third row, or third orbit, or third shell. Shell's the proper term if you're doing this the right way. So 1, 2, 3, 4, and then you start pairing them up. What would my Lewis dot diagram look like? 1, 2, 3, 4, 5, 6, 7, because fluorine is in the 7th column. Some of this information may not be important. I'm trying to give you a full picture with some background, but you should know how to get your protons, neutrons, and electrons. Now, let's go over 2 terms. Let's go over isotope and isomer. So iso means different, tope means atom, so different forms of the same atom. So the most popular form of hydrogen has 1 proton, 1 electron, and 0 neutrons. Another isotope, or form of hydrogen, is tritium. Tritium has 1 proton, 1 electron, and 2 neutrons. These are often radioactive when we have isotopes, so when we have different forms of neutron, or different number of neutrons, because they can break down and give off radioactivity. Okay, I said I wanted to go over a couple of different terms. Let's go over charges right now. So let's go over lithium 1+. If we have lithium 1+, we have 3 protons and we have 3 electrons. Now, if we have a 1+ charge, we've got 1 more plus than we do negatives. You can never change the proton number. Let me say that again, it's really important. You can never change the proton number in an atom, but you can change the electron number. So we have 1 less negative than we do positives. We've got 2 positives, or we've got 3 positives and 2 negatives. So we've got 1 more positive than negative. Always write down these so they're equal, and then change your electron number to suit the charge. Oxygen 8, 16, 2 negatives. 8 protons and 8 electrons is the normal, but I have a 2 minus charge, so I have to have 2 more minuses than positives. Okay, so when we have charges on things, this is how you take care of the charges, by leaving the proton numbers the same and changing the electron numbers. That's very important. So these are called ions. This is when we get charges. If you want to know what charges you can get, if we are on the main part of the periodic table, anything in this column can become 1+, 2+, let's jump over here, 3+, 4+ or 4-, 3-, 2-, 1-, no charge. Okay, all of these elements gain electrons. All of these elements lose electrons over here. Folks, have fun with activity U2A1 and make me a nice looking timeline.